Suppose that an airplane flying at a constant velocity of 60 meters per second, at a height of 300 meters, dropped a sack of flour. The two parts of this problem are: Part A, how far from the point of release would the sack have traveled when it struck the ground? And B, where will the plane be in relation to the sack when the sack hits the ground? We are making the assumption that the airplane is not only flying at a constant velocity of 60 meters per second, but it is flying perfectly level with the ground. That means that this will be a horizontally launched projectile problem. That will allow us to make some assumptions when we're filling in our list of horizontal and vertical variables. Now, we're going to define our drop point as our position 0, or 0 meters, for our horizontal starting position. We are looking for the final position. That is how far from the point of release would the sack have traveled when it struck the ground. We're making the assumption that the plane and the sack of flour would have the same starting horizontal velocity of 60 meters per second. And because this is a projectile, the sack of flour would have 0 horizontal acceleration. Now, the starting position of the sack of flour vertically would be its height of 300 meters, and it ends up on the ground, that final position of 0 meters. Because it's a horizontally launched projectile, that assumption we're making, that means the starting vertical velocity would be 0. And we do not know what the velocity would be the instant the sack of flour strikes the ground. And we are not provided the time. In order to figure out how far from the point of release would the sack have traveled when it struck the ground, we need to first figure out the amount of time the sack of flour was in the air for, and then figure out how far horizontally it would have gone. So, to start off with, we're going to select an equation from our vertical list that will allow us to figure out our time. We know that our starting position is 300 meters and our final position is 0 meters. We know our starting velocity is 0 meters per second. We do not know our time, but that is what we're solving for. And we know that our acceleration is negative 9.8 meters per second squared. Simplifying this down and rearranging it, we have 300 meters is equal to, negative 300 meters is equal to negative 4.9 meters per second squared times time squared. Dividing both sides by negative 4.9 meters per second squared gives us a value of 61.2 with the units second squared. That's equal to time squared. Taking the square root of both sides will give us a time of 7.8 seconds. That is the amount of time that the sack of flour is in the air for before it strikes the ground. So that is going to be a variable we can update in our list. Once again, time is the variable that links our horizontal and vertical variable lists together. So to figure out how far the sack of flour would have traveled horizontally, we take our equation that we used in the previous part, but just now it's its horizontal counterpart. Plug in the values we know. We're solving for that final position x, so we leave that as its variable. But we know it starts off at a position of 0 meters. It starts off with that initial velocity of 60 meters per second. It's traveling 60 meters per second for 7.8 seconds while it's a projectile. And we have 0 horizontal acceleration. Simplifying this down will give us 0 meters plus 468 meters plus 0 meters, which means that the sack of flour would have traveled horizontally 468 meters. Now, to answer part B, where will the plane be in relation to the sack when the sack hits the ground? Well, we can go with that same list of horizontal variables. We know that the plane, when it drops the flour, would be at a horizontal position of 0 meters. It is traveling at that constant speed of 60 meters per second. Because it's a constant velocity for the plane, that means the horizontal acceleration is 0. And then we're trying to figure out what the position would be 7.8 seconds later. Plugging in the variables, we figure out that the plane is at the exact same horizontal position that it once was. And because the plane we're assuming is flying level with the ground, it means that its vertical position would not have changed. So really, our answer for this part of the problem is twofold. The plane will be at the same horizontal position as the sack of flour, and the plane will be at a vertical position 300 meters above the sack of flour.